Hi friends, in this video I will explain the concept of carrier sense multiple access for 6 marks or maybe 7 marks. So carrier sense multiple access, it is shortly known as a CSMA. Carrier sense multiple access require that each station first listen to the medium before sending. So the reason for this is shown below figure, a space and time model of a CSMA network. If stations are connected to a shared channel, the possibility of collision still exists because of the propagation delay. So when a station sends a frame, it still takes the time for first bit to reach every station and then for every station to sense it. So as a name itself, it is going to indicating carrier sense. Whenever the frame it has been arriving at the time, it is going to sense. At time t1, station B sends the medium and finds it to idle. So here, if you look at this diagram, you will come to know that at what and all the time which will be active and then idle. So it sends a frame at time t2. T2 is greater than t1. Station C sends the medium and finds it is idle, because at this time the first bit from station B has not reached to the station C. So station C also sends a frame, the two signals collide and both the frames are destroyed. So if we take an example of T1, okay, T1 it has been started and then T2 it has been started. So and then it is going to check at what and all the time it has been which we are in the idle. So area where A signals it has been exist. So here it has been started and then this is the portion for T1 it has been sending a frame. So and then from here, so here to here, which will be having the what T2 segments, area where both the signals it has been exist. So this darker shade which is going to indicating what the corresponding it has been existing the collision. And then the B starts at the time at T1 and then C starts at the time T2. So next, vulnerable time. The vulnerable time for CSM is a propagation time dp. This is the time needed for a signal to propagate from one end of a medium to another. So when a station sends a frame and any other stations try to send a frame during this time, a collision which will result. So below figure shows the worst case. The leftmost station A sends a frame at time 1, which reaches the rightmost station D at a time T1 plus Tp. So T1 it has been started and then which is going to reaching on to the what T1 plus Tp. This is the what vulnerable time is equal to the propagation time. So next another important thing under the CSMA is a persistence method. What should the station do the channel is busy and what should the station do the channel is idle? Three methods have been division to answer the question, which is with the so first which will be the one persistent method and the non-persistent method and then p persistent method. So below figure shows the behavior of three persistent method when the station finds a channel it is busy. So first it is a one persistent. The continuously it is going to keeps on sensing and then it will transmit. So we are going to which means it is going to indicating busy. So and then no non-persistent and then it is going to sense it and then it which will be busy and then it will wait and then it will sense and then it will be waiting. So and then the p persistent method, so send if r is less than p, wait for a time slot, otherwise wait back of a time. So wait time slot otherwise. So like that we will be having the three different methods are present. So in this one persistent method, after the station finds the line is idle, it sends its frame immediately. This method has the highest chance of collision because two or more stations may find the line idle at the same time and send their frame immediately. And the non-persistent, a station that has a frame to sends the line. If the line is idle, it sends immediately. If the line is not idle, it waits the random amount of time and then sends the line again. So this it is going to waiting and then next it is going to sense at the time it will send. So the non-persistent approach reduces the channel of collision because it is unlikely that two or more stations will wait the same amount of time and retry to send the simultaneously. So next p persistent method. So if If the channel has a time slot with the slot duration equal to the greater than the maximum propagation time, the P persistent approach combines the advantages of other two strategies. It reduces the chance of collision and improves the efficiency. In this the method, after the station finds the line idle, the following steps it has been occurring. So first, with the probability P, the station sends its frame. With the probability Q is equal to 1 minus P, the station waits for a beginning of the time slot and checks the line again. If the line is idle, it goes to the step 1. Otherwise, if the line is busy, it acts as if the collision has occurred and uses the back-off procedure. So and then below is the what the flow diagram it has been given for a 3 persistent method in the below diagram. So persistence. So first it is going to channel is busy, right? If it is true, it will come again to the beginning. If it is false, station can transmit. So next station non-persistent, it will be idle, and then whenever it has been started onto the condition it is busy. If it is true, wait for a randomly, right, and then it is going to send. If the condition it has been false, station can transmit. And then P persistent, here initially the channel is busy, and then if this condition is false, it will come here, otherwise it will come here. And then if the channel is busy false, then generate a random number r is equal to 0 to 1, and then it is going to giving the instruction to the next the condition. If that condition is false, wait for a slot, right, and then the busy, like that it is going to keeps on repeating until it has been reaches onto the corresponding the condition.